Um, okay. I thought I fixed it, but I guess I didn't. Give me another second. Okay. You can't see my wings. What's the point of this? Hi. Wow, that took a while. Yeah, it has been. Oh, it has been like how long? It's been like almost not a week, but almost a week. So I've been gone for so long. Sorry about that. I just wasn't really feeling. Hi. I wasn't feeling really well the past week, and sorry for it's been a while for keeping you in the dark. I don't know. I was quite unmotivated, and also not well. So it was a combination of different things. And even today I was like I wasn't really feeling it. So I'm here against all odds. And thank you for being here. It really is motivating to have someone else with me, even though like it's weak of me to be like that, but I don't always want to learn new things. I'm not like, Thank you. Yes, I am better now. It wasn't anything serious, but yeah, it was a mix of not feeling well and not being motivated. How are you? How have you been? How's life treating you? I changed the background. I really like it. But now I feel it makes me look really small because I made myself zoom out. And yeah, I'm gonna go to the screen, and let's see if this time when I share my screen it's actually this screen. Let's do that. Voila. And if I change it, it does change. Yay. But apparently
Across every data set where
wait,
you use it.
Jeremy. Yeah, thank you. I'm glad you like it. I still have the other screen there. Where is it? Yeah, if I hide this, the other is in the background, and if I show this, the other is gone. So now I can have two things, and sorta like you can sorta see this part of the window. So like if it makes it look like I'm going to the window, sort of. Yeah. Yeah, I'm guessing the image behind me was AI. I didn't create it, but I'm guessing it was AI created because the keyboard looks wacky. Yeah. Okay. Should we do some studying? I'll zoom this out so that you can see the whole wing, and then make her bigger so that there. Come on, you can do it. All right. The wing looks weird. Should I change it? Because I think we have other colors. But I don't think I own them. Oh well, I can do that next time. Apparently the streaming is horrendous. Wow, I just noticed that. Sorry about that. Okay. You can see me, you should be able to hear me. Alright. I'm gonna... Yeah. Okay, thank you. Sorry, I just see that the drop rate is really high and the streaming isn't good. That's why I sort of froze. If there are issues, let me know. I'll try to fix it. But no promises also. Yeah. Okay. So, recap time. Hello. Welcome to another lesson 20. I mean, it's lesson 8, but it's the 23rd lesson on our side of the Introduction to Machine Learning for Coders, a course from fast.ai by Jeremy Howard. Yeah, we have been at this for a while because it's normally my fault. I've been not really consistent. If you can believe it, we are in lesson 8. Yeah. Aren't we? Yeah. We finished all the random forests, and lesson 8 is gradient descent and logistic regression. So we're getting to the fun part. Yeah. And I'm gonna go to the lesson. We're halfway through lesson 8, so even though, yeah, I'm gonna go back because I have no idea what we were doing. Yeah. Okay. I'm gonna play it and see if I remember anything. How about that?
Right? So we actually want to use the same normalization coefficient.
Okay. Something about normalizing. Really? Okay, I remember some things, but I still need to go back.
That contained green frogs, green snakes, and gray elephants, right? We're trying to figure out which was which. And we normalized using, each channel mean. And then we have a validation set and a test set, which are just green frogs and green snakes. So if we were to normalize by the validation...
We're discussing random forests here, I think. Comparing random forests to gradient descent or something? I don't know.
Sets statistics, we would end up saying things on average are green, and so we would remove all the greenness out. And so we would now fail to recognize the green frogs and the green snakes effectively, right? So we actually want to use the same normalization coefficients that we were training on. And for those of you doing the deep learning class, we actually go further than that. When we use a pre-trained network, we have to use the same normalization coefficients that the original authors trained on. So the idea is that, a number needs to have this consistent meaning across every data set where you use it.
Which is why we're using, we are doing validation separately, and so that they mean the same thing. I think that's where we were.
Can you pass it to us, Mita?
That means when you're looking at the test set, you normalize the test set based on this mean set?
That's right.
Okay.
That's right. Okay. So here's a, so the validation Y values are just rank 1 tensor of 10,000. Remember, there's this kind of weird Python thing where a tuple with just one thing in it needs a trailing comma.
Mm-hmm.
Okay, so this is a rank 1 tensor of length 10,000, and
also known as an array, but yes, we have to learn to say rank 1 tensor.
So here's an example of something from that. It's just the number 3. Right? So that's our labels. So here's another thing you need to be able to do in your sleep. Slicing into a tensor. So in this case, we're slicing into the first axis with 0. So that means we're grabbing the first slice. So because this is a single number, this is going to reduce the rank of the tensor by 1. It's going to turn it from a 3-dimensional tensor into a 2-dimensional tensor, right?
Whoa.
So you can see here, this is now just a matrix.
So 10 to 15, 10 to 15, okay. So like if we had a normal array, we would say give me from 0 to 5, we'd get those 6 numbers, indexes 0 to 5. But now this is it 2 dimensions? X image? Anyway, let's see.
And then we're going to grab 10 through 14 inclusive rows, 10 through 14 inclusive columns, and here it is, right? So this is the kind of thing...
Rows and columns, okay. So it's like the way I see it is like getting a subset of the matrix.
You need to be super comfortable, like grabbing pieces out, looking at the numbers, and looking at the picture, right? So here's an example of a little piece of that first image.
Fancy.
And so you kind of want to get used to this idea that if...
He said no, right? Because we're looking at a 2D image. Also, didn't he say this 0 thing takes it down 1 dimension? So was it 3 dimensions before? I don't think so. 0 for the first dimension, for the second and third. I don't know, because like we're saying row column or column row. I don't know which one this is. Okay, should I go back and see exactly what he said so that we understand it better? Okay.
So that's our labels. So here's another thing you need to be able to do in your sleep. Slicing into a tensor. So in this case, we're slicing into the first axis with 0. So that means we're grabbing the first slice. So because this is a single number, this is going to reduce the rank of the tensor by 1. It's going to turn it from a 3-dimensional tensor into a 2-dimensional tensor, right? So you can see here.
Do you understand what he's saying? Third one, choose between red. I'm not sure. But like this is sort of a row column. This is something to do with the first axis, I think.
So because this is a single number, that means we're slicing into the first axis with 0. So that means we're grabbing the first slice.
Oh, you're right, dude. Sorry. First slice, which probably, I think we only have one size. Isn't it just black and white? You're right. I mean, it's the first one that gives you this choice, right? Instead of the third one.
So because this is a single number, this is going to reduce the rank of the tensor by 1. It's going to turn it from a 3-dimensional tensor into a 2-dimensional tensor, right? So you can see here, this is now just a matrix. And then we're going to grab 10 through 14 inclusive rows, 10 through 14 inclusive columns, and here it is, right? So this is the kind of thing you need to be super comfortable, like grabbing pieces out, looking at the numbers, and looking at the picture, right? So here's an example of a little piece of that first image. And so you kind of want to get used to this idea that if you're working with something like pictures or audio, this is something your brain's really good at interpreting, right? So like keep showing pictures of what you're doing whenever you can. But also remember behind the scenes they're numbers. So like if something's going weird, print out a few of the actual numbers. You might find somehow some of them have become infinity, or they're all zero, or whatever, right? So like use this interactive environment and to explore the data as you go.
And also look at the picture and also look at the numbers. Good advice.
Did you have a question? Where's the...
I think something very blessed is happening around me. Do you hear the roosters? I mean, it's just sunrise. Just sunrise. Sunrise is amazing. Okay.
box up?
Just a quick, I guess, semantic question. Why, when it's a tensor of rank 3, is it stored as like XYZ instead of, like, to me it would make more sense to store it as like a list of like 2D tensors.
It's not stored as either, right? So
Really?
For the formatting, because
let's look at this as a 3D. Okay, so here's a 3D, right? So a 3D tensor is formatted as showing a...
That's a really cool rooster. I don't think ours is this cool, but he's pretty cool.
list of 2D tensors, basically.
But when you're extracting it, why isn't it, like, if you're extracting the first one, why isn't it X images, square bracket 0, close square brackets, and then a second set of square brackets?
Oh, because that has a different meaning, right? So it's kind of the difference between tensors and jagged arrays, right? So basically, if you do like something like that, that says take the second list item and from it grab the third list item. And so we tend to use that when we have something called a jagged array, which is where each subarray may be of a different length, right? Whereas we have like a single object of 3 dimensions. And so we're trying to say...
I don't think I've heard of jagged arrays, but I also get it. Like I probably have lists of lists where they're not the same length. But just the term jagged array is new to me.
Like, which little piece of it do we want? And so the idea is that that is a single slice object to go in and grab that piece out. Okay. So here's an example of a few of those images along with their...
I just realized I have this lesson. Did I use it? Did I not use it? Yeah, lesson 4. I have it. I think that's what we're looking at. Yep, lesson 4. Do I already have it? This is lesson 2. This is lesson 1. Oh, yep. Same thing. Normalize, look at the data, plots, yeah. Shoot, neural networks. Is that what we're... So what we're going to be talking about? If so, I'm going to, do some reviews in the notebook.
labels. And this kind of stuff you want to be able to do pretty quickly with Matplotlib. It's going to help you a lot in life, in your exam. So you can have a look at what Rachel wrote here when she wrote plots. We can use add subplot to basically create those little separate plots. And you need to know that IMShow is how we basically take a NumPy array and draw it as a picture. Okay, and then we've also added the title on top. So there it is. All right, so let's now
go to the notebook. Let's see if it works. Says no data. Let's see if we can get it. Import data. Okay. Session starting. Have you used these notebooks or tried to run any of the other notebooks? Or okay. Torch imports? Is that a warning? It's a deprecation warning, not an error. Why does it look so red? I don't have that. I don't have data. Oh, make directories? Oh, import. Ah, that's cool. That's output. That's not input. This particular notebook. No, these. Are you running these notebooks? Because we're supposed to be studying them. That was scary. Hide. Okay. And then show. Yes. Do I have the data now? Okay, we got it from deeplearning.net. Got it. Getting the data. I once got yeah. It can be scary, but it's really loud when it's next to a microphone. And they're even louder when you put them on a surface. I don't know if you've ever done that, but if you put, which I do it, whatever, put your phone under your pillow and it's only, your wake up ringing tone is only vibration. Like, it feels like your whole head is moving. Depending. Not really, but like still. Whoever invented phone vibrations, like, good job. It's annoying, but it's good. That's taken its time. Now I've gotten mad enough that I feel like I should go back to the lesson and come back to you later. Okay, goodbye, mister.
Take that data and try to build a neural network with it. And so
the MNIST data, okay?
A neural network, and sorry, this is going to be a lot of review for those of you already doing deep learning. A neural network is just a particular mathematical function or a class of mathematical functions. But it's a really important class because it has the property, it supports what's called the universal approximation theorem, which means that a neural network can approximate any.
I have no idea what's the universal approximation theorem, but I could approximate.
Other function arbitrarily closely, right? So in other words, it can do
gamepad. Ah, it was on the table. That's why it was louder. Yeah. Okay, because I didn't know if there was a vibrating remote control as like TV controls vibrate. But yeah, you mean a game controller, obviously. The only gaming I've done have been on PC or phone, so I'm not used to. But I've used game controllers, just not as much. And when you like do something wrong and it vibrates in your hands, like gives you feedback.
In theory, it can do anything, as long as we make it big enough. So this is very different to a function like 3x plus 5, right? Mm-hmm. Which can only do one thing. It's a specific function.
Estimation theorem claims that a big enough neural network can approximate any function regardless of overfitting. Okay. So it's a theorem within neural networks? I thought it was an already existing one. Not that it matters to me. Cool. Okay. It's, it's like saying random forest falls flat because of it's not being able to predict, right? So is the approximation theorem about that? Approximating things that is outside of its training? Maybe. I watched Pantheon. I finished watching Pantheon yesterday, and I still can't stop thinking about it. It's a TV show, an animated TV show about, it's a lot more technology. So that was, yeah. It becomes really abstract really soon, but still, it's really cool. If you haven't watched it, watch it if you want.
Or the class of functions ax plus b, which can only represent lines of different slopes moving it up and down different amounts. Or even the function ax squared plus bx plus c plus sine d, again, only can represent a very specific subset of relationships. The neural network, however, is a function that can represent any other function to arbitrarily close accuracy. Right.
Cool. Okay.
So what we're going to do is we're going to learn how to take a function, and so let's take like ax plus b, and we're going to learn how to find its parameters, in this case a and b, which allow it to fit as closely as possible to a set of data. And so this here is showing an example from a notebook that we'll be looking at in the deep learning course, which basically shows what happens when we use something called stochastic gradient descent to try and set A and B. And basically what happens is we're going to pick a random...
Okay. Yeah, it is pretty interesting. Whenever I find any TV show, movie that talks about technology, programming, and AI, whatever, anything computer related, I'm like, I need to watch it. So if you have recommendations too, let me know.
Random A to start with, a random B to start with, and then we're going to basically figure out, do I need to increase or decrease A to make it closer, the line closer to the dots? Do I need to increase or decrease B to make the line closer to the dots? And then just keep increasing and decreasing A and B lots and lots of times. Okay? So that's what we're going to do. And to answer the question, do I need to increase or decrease A and B, we're going to take the derivative. Right? So the derivative of the function with respect to A and B tells us how will that function change as we change A and B. Right? Okay. So that's basically what we're going to do. But we're not going to start with just a line. The idea is we're going to build up to actually having a neural net. And so it's going to be exactly the same idea, but because it's an infinitely flexible function, we're going to be able to use this exact same technique to fit arbitrarily complex relationships. That's basically the idea. So then what you need to know is that a neural net is actually a very simple thing. A neural net actually is something which takes as input, let's say we've got a vector.
Oh, okay. Because like in my head I was like, you can feed it anything, but I guess you have to make it palatable for the function. Like if it's an image, if it's text, if it's... What else is there? basically everything is either image or text. Video, image, you know? What else is there? I mean, numbers, but images are numbers. Okay, maybe we could even debate that numbers are images. What?
Does a matrix product by that vector, right? So if this is of size, let's draw this properly. So like if this is size R, this is like R by C, a matrix product will spit out something of
Row column?
size C, right? And then we do something called a nonlinearity, which is basically we're going to throw away all the negative values. So it's basically max 0, x. And then we're going to put that through another matrix multiply. And then we're going to put that through...
Oh, God. Okay, I'm trying to follow.
Another max 0, x. And we're going to put that through another matrix multiply, and so on. Right?
I'm lost. Okay, oh, so you're saying that it has multiple layers. That's why we're saying it puts that, right?
Right? Until eventually we end up with the single vector that we want. In other words, each stage of our neural network is the key thing going on is a matrix multiply. So in other words, a linear function. So basically deep learning, most of the calculation is lots and lots of linear functions, but between each one, we're going to replace the negative numbers with zeros. Can you pass it?
Okay. That seems
yes.
Easy to
So
understand.
why are we throwing away the negative numbers as we go through this process?
We'll see. Right. The short answer is, if you apply a linear function to a linear function to a linear function, it's still just a linear function. Okay. So it's totally useless. But if you throw away the negatives, that's actually a non-linear transformation. And so it turns out that if you apply a linear function to the thing where you threw away the negatives, and apply that to a linear function, that creates a neural network. And it turns out
each layer extracts a certain level of details until we reach the final prediction. Yes. And yeah, like it gets, you've probably watched the one brown, three brown, one blue, videos where you even can see what's in each layer, and it becomes, very abstract that you're like, what detail is this? But yes.
That's a thing that can approximate any other function arbitrarily closely. So this tiny little difference actually makes all the difference. And if you're interested in it, check out the deep learning video where we cover this, because I actually show a nice visual intuitive proof, not something that I created, but something that Michael Nielsen created. Or if you want to skip straight to his website, you could go to Michael Nielsen, Universal, I think I spelled his name wrong, never mind, Hessian theorem. There we go. Neural Networks and Deep Learning, Chapter 4, and he's got a really nice
That's a book.
walkthrough, basically, with lots of animations where you can see why this works. I feel like the hardest thing. I feel like the hardest thing with getting started, like technical writing on the internet, is just like posting your first thing. If you do a search for Rachel Thomas Medium blog, you'll find this. We'll put it on the lesson wiki, where she talks about, she actually says the top advice she would give to her younger self would be to start blogging sooner.
Yeah, I should also, like, blogging is different from, oh, you do. I don't think I do. Yeah, blogging is, I've tried my hand at it. I've never continued, and it's like so different from like making or streaming or anything like that. Yeah, learning to communicate well is, I mean, yes, talking is a way of communication, but through writing, this is a weird thing to say, but if you've read the Leonardo da Vinci book, written by Isaac Water, what? Something? No, wait, something. Oh, shoot. I forgot the author's name. But if you read the Leonardo da Vinci's biography, you'll know that his main thing was writing in journals. Whether it was for planning, it was for, just journal. So it motivated me to have a daily work notebook. I mean, it doesn't actually have to be a physical book. It can be digital, which mine is digital. But any form of writing stays and is, it helps you learn better. See? Literally, second point, helps you learn. Yes.
And she has both reasons why you should do it, some examples of things that, examples of places she's blogged and it's turned out to be great for her and her career, but then some tips about how to get started. I remember when I first suggested to Rachel she might think about blogging because she had so much interesting to say, and, at first she was kind of surprised at the idea that, she could blog.
Yeah.
And now people come up to us at conferences and they're like, oh, you're Rachel Thomas, I love your writing. So I've kind of seen that transition from wow, could I blog to being known as a strong technical author.
Okay. This is very motivating. Not that, I don't know. I do like documenting. Yeah, and you have to sort of put some heart into whatever you're doing, but it doesn't have to be personal information. Just
so check out this article if you still need convincing or if you're wondering how to get started. And since the first one is the hardest, maybe your first one should be something really easy for you to write. So it could be here's a summary of the first 15 minutes of lesson 3 of our machine learning course. Here's why it's interesting, here's what we learned. Or it could be here's a summary of how I used a random forest to solve a particular problem in my practicum. I often get questions like, my practicum, my organization, we've got sensitive commercial data. That's fine. Just find another data set and do it on that instead to show the example, or, anonymize all of the values and change the names of the variables or whatever. You can talk to your employer or your practicum partner to make sure that they're comfortable with whatever it is you're writing. In general, though, people love it when their interns and staff blog about what they're working on because it makes them look super cool. It's hey, I'm an intern working at this company and I wrote this post about this cool analysis I did, and then other people will be like, wow, that looks like a great company to work for. So generally speaking, you should find people are pretty supportive. Besides which, there's lots and lots of data sets out there available. So even if you can't base it on the work you're doing, you can find something similar for sure. All right. So we're going to start building our neural network. We're going to build it using something called...
Just checking. What time is it? Okay. Just checking my notebook. Hello. You look lovely. Connection timed out? Oh, bad internet. I'm sorry. Let's try again. Is that possible? Take your time, kiddo. Okay. What are we doing? GPUs, PyTorch is... Ooh! Anything AWS.
PyTorch. PyTorch is a library that basically looks a lot like NumPy. But
I feel like I should really stop there. Like,
all right.
yes, here. I think I can stop there, but I do want to see if I can get this little guide to run. That doesn't seem possible. What was the book's name? Wait. Oh, did you... Neural networks in deep learning. There it is. When was it written? 2017. Okay, that's not that old. And that's the website. Is it free? It is a free book. But isn't also the deep learning book by there it is. Ian Goodfellow and Joshua Bino something. Isn't this book also free-ish? Yes, it's free-ish. Yeah, it's a text pack. This is like one of the books that I'm like, can I read? Can I look at it? If you had to choose one of them, which one would you choose? Neural networks and deep learning. So like this is approach. Michael Nielsen. I'm guessing this was updated, right? Because even this one has to be updated. Yes, this is 2016. Was written 2016. But I think I've even read like some of the pages, and I like it. We have like just a math overview, linear algebra, probability and information theory, numerical computation. Oh shoot, I'll be back. Machine learning basics, modern practical deep networks. Which one? This one? I'm looking at two different things. Which one is this one? Deep feed-forward networks, regularization for deep learning. This is all deep learning, right? Optimization for training deep models. The one that goes more in depth in math. Is it this one? The Ian Goodfellow one or the Michael Nielsen one? Because I don't know what are the chapters. Are these the chapters? What is the book about? Let's look at that. Can you give me the chapters? Hands on, that's cool. Using... Wow, that feels really hands-on. Like, first thing is like, let's recognize handwritten digits. The other one. The Ian Goodfellow one? I don't know. Or the Michael Nielsen one. This one. Deep learning. .org? Oh, okay, this one. deeplearningbook.org is heavier in math, is it? Okay. Coolsies. I really don't know which one is better. I just know this one's more recognized because it's like really, really famous people. I don't really know the third guy, but I know the first two guy. And isn't Joshua one of the people who got Alan Turing Award? Yeah, he got the Turing Award. Alongside with Geoffrey Hinton and Jan LeCun, I think. Yeah. Because it's a more beginner friendly book. Still same error. Timeout. That just timeout. That's it. Why though? Okay, so this is like two different lines. If I cut them, and have it be like this, would we still time out? Okay. I think I gotta go time. Didn't really do anything interesting or fascinating today. But we did learn about some cool things, and that is cool. And I think my wings are pretty cool. I like how mechanical they look. Oh, okay, wow, that looks grainy. Anyway, that thing's still running, and I think, yeah, like I actually tried our book, like if I should study it or not, but I think I voted against it, even though I made a really cool thumbnail for it. Yeah, I don't think I'm gonna take that course as like live streaming. I think I will focus on Python and AI related things, because if inshallah I get accepted for my PhD, that one will be more useful. The R one I'll learn along the way at work. Still loading. Okay. So happy Friday. I didn't, still error. Okay, same error. Anywho, I didn't know I am matching my room, this room. I am matching it really well. Thank you for being here. Thank you for helping me learn and for Googling things when I'm too lazy to do so. I hope you have a lovely day, and I hope you get to rest because it's a Friday. Learning isn't the most important thing. Sometimes it's, taking care of yourself. And as as hopefully not a spoiler in the pantheon, sometimes it's even other people. They matter. So yeah, let's be nice and to ourselves and to other people, and enjoy our weekend and try to learn along the way. Yeah, that became too philosophical. Yep, that's all. Thanks for tolerating me, and enjoy your day. I'm gonna end the stream starting with 10 because it's horrible. Yes, you're right. Literally, even if you go to the gym, like they tell you sleep is really important, which is obviously true. So yes, also with learning, resting is part of it. Yep. Thank you for that. Okay, I'm gonna go in 10, 9, 8, 7, 6, 5, 4, 3, 2, blast off.